Hello, welcome to our video solution to problem 11 from Superquiz 2, another optional problem. This is very similar to a problem from Superquiz 1. This is an example of one of De Morgan's laws. In Superquiz 1, I'll put a link to that problem in the description, we looked at the complement of an intersection and showed that it is equal to the union of the complements. In this problem, we show sort of the dual statement, namely that the complement of a union is equal to the intersection of the complements. So all of these sets A and B have to live inside some universal set U. Fine, we set that up at the beginning. And remember this notation A complement. This denotes all the elements of U that are not in the set A. Okay, so these are all elements in U which are not in the set A. That is the complement. All right, and so we want to show an equality between two sets. What does that mean, right? Well, two sets are the same if they have the same elements. So what I want to do is actually show that any element in the left side is an element of the right and vice versa. So we have, well, let's start with an element. Let's take some element in U. We have that X is going to be in the union complement, right? So the complement of the union. Well, what does that mean? That means that it's in U, but it's not in A union B. So if and only if X is an element of U and X is not an element of A union B. Okay, so what does it mean? Well, X being in U, well, we already knew that. So we could actually just ignore that part, right? And just say, okay, X is an element, or is not an element of A union B. Okay, what does it mean that X is not an element of A union B? Well, what is A union B? A union B is all the elements that are in A or in B, right? Which allows for them to be in both, of course. So saying that X is not in the union is equivalent to saying that X is not an element of A and X is not an element of B. Well, what does it mean that X is not an element of A? Well, if it's not an element of A, and we already know it's an element of U, then we know that X is an element of the complement of A. So this is equivalent to saying that X is in the complement of A, and for the same reasons, X is in the complement of B. But when you're in two sets, you're also in their intersection, and vice versa. So this is equivalent to saying that X is in the intersection of the complement of A and the complement of B. But this is exactly what we wanted to show. If we have an element in the complement of A union B, then that same element is in the intersection of the complements of A and B. And because these implications are bidirectional, right? Each one of these was if and only if, we actually have that every element in the intersection of the complements is an element in the complement of the intersections. So it follows that every element of A union B complement is an element of the intersection of A complement and B complement, and vice versa. Thus, A union B complement equals A complement intersect B complement.